Hello everyone and welcome to Physical Science. Today we are going to be starting our Unit 6 on motion. Unit 6, Section 1, we're going to talk about distance versus displacement. Alright, so distance, you kind of already have an idea of what that is, from life. Displacement though, displacement is talking about how far you are from where you started. So you could move around a lot and not be displaced. You'll see what I mean. Okay, so motion. Let's start off with motion. You intuitively know that motion is something that is moving. But then why would you use move in terms of motion and definition? So here is what we are going to define motion as. So motion occurs when some things happen. An object moves a certain distance in a certain amount of time. Okay, so motion occurs when you are moving over a time period. And an object changes position. So it is not where it started. So we're going to be talking about how things can move around, back and forth. The first thing we need to know is that if you are talking about motion, the only way that you can determine that motion is occurring is by having a frame of reference. I'm sure that you have been riding down the road in a car and had a car right beside you and looked out the window and kind of felt a little bit like you weren't moving because you were both moving side by side at the same speed. So if you were just looking at the car beside you, you'd have no idea that you were moving. But if you look off at a tree on the side of the road, you can definitely tell how fast you're moving. So, frame of reference. In order to describe motion, you need frame of reference. And what frame of reference is something static or not moving to compare your motion to. So here's how I like to think about it. You are driving down the road. Let's say you're driving down the road. Boo, boo, boo. And as you're driving down the road, you have a car right beside you. And let's say that you're going the same speed. If you are going the same speed and you look out the window at this car and you're only looking at the car, it's not going to look like you're moving because you don't have a static, not moving thing to show that you're moving. But on the side of the road is this lovely tree, and you look at the tree instead. The tree is static or not moving compared to you. So you're going to be able to tell how fast you're going. So in order for you to know that motion is occurring, you're going to have a frame of reference or something static to compare your motion to. Otherwise, you're not going to know. So if you are stationary, and Jackie is rolling at 9 kilometers per hour, you're going to be able to tell that Jackie is moving, and if Jackie looks at you, she'll be able to tell that she is moving because you are the frame of reference. You are stationary. You will be able to tell. But in this instance, where Jackie is stationary and you are rolling at 90 kilometers per hour, if you are moving in relationship to Jackie and Jackie is the frame of reference, that's how you're going to tell that you're moving. So it depends on what is considered stationary. The stationary object, the one that is not moving, is going to be your frame of reference. Okay, so let's talk about motion and distance. Distance is how far? Done. Okay, yeah. And the units are measured in meters. So measured in meters or some other variation of meters, kilometers, centimeters, millimeters. Who thinks it's weird that you say kilometers and then centimeters and then kilometers? I don't know. It's a weird word. So when you're trying to figure out distance, you need to look at a stationary point. Again, so let's say that you're the star. I'm a star. And I'm moving from here, boop, to here, boop, to here, boop, to here. If I asked you what distance you traveled, you could probably do this pretty easily without me ever even telling you. Because you go 2, and you go 4, and you go 2, and you go 4. Well, 4 and 4 is 8. 9, 10, 11, 12. So your distance is your 2 plus 4 plus 2 plus 4, because you went 2, 4, 2, and 4. You traveled a total of 12 meters. Okay, not hard. You just traveled 12. If you're trying to figure out distance, you just add them all up. Displacement is a whole totally different thing. Displacement is your change in position from its start point. So I'm going to use that same example. I'm going to show you the difference between distance and displacement. So you're the star again, of course, and you are going to do the same path. Well, displacement is how far you are from where you started. Well, if you're the star and you traveled the same path, how far are you from where you started? Are you any different from where you started? No. So your displacement would actually be 0. So in this case, displacement is 0 if you're starting and ending are the same. No matter how much distance you have traveled, your displacement is going to be 0. You could travel 1,000,000 miles, and if you end up where you started, your displacement is 0. So the difference between, so if we're going to break it down, it's the difference between the ending and starting position, how far you are from where you started. So distance would still be 12, but your displacement is 0 because you have not moved. So let's do another example. So you're a skier, and you're just going to travel from A to B. Let's look at our distance to start off with. Well, if I'm going from A to B, I'm going 40 plus 100 plus another 40. So that means I'm traveling a total distance of 180 meters. Where did I get that from? 40 plus 100 plus 40. If I'm looking at displacement, I need to figure out how far I are from where I started. So if I end here and I started here, well, that's the same in this case. Because if I'm over here, I'm still 40 plus 100 plus 40 away from where I started. So 180 meters. So your distance and displacement can be the same, but doesn't necessarily have to be the same. So with that same type of example, let's talk about it if we went from not just A to B, but let's say we went from A to B, and then he turned around and came back to C, and then stopped. Well, my distance is 40, right here, plus 100, right here, and then he travels another 40, and then he turns around and he goes back 40, and then he goes another 100, and then he stops. So then we have to do the math on that. So we have 40 plus 100 plus 40 plus 40 plus 100. If you add all those up together, you end up with a total of 320 meters. But let's look at our displacement. Okay, I'm not going to add every distance up because all I care about with displacement is how far I am from where I started. Well, if I started at A and I end over here at C, I need to figure out how far I am from where I started. Well, if you see, if you see, then you are 40 meters away from where you started, because here you are, you started here at 0, so your displacement is 40 meters. But let's say you're not traveling just in straight lines back and forth. Let's say that you travel in a triangle, because people travel in perfect triangles somehow. I don't know. But let's say you are. And let's say that this person is traveling from A to B to C. Well, the first thing I want to figure out is my distance. And all I have to do to figure out distance, we've seen, is to add. So from A to B is 4, and from B to C is 3. So we have a total distance of 7 meters. But let's look at my displacement. Oh no, if I started here and I ended up here, there's no like number line for me to figure this out. Okay, but I can figure it out by using math. Let's do some math. So this is a triangle, and if you remember from math class, you can use Pythagorean theorem to figure out distances on a right triangle. So the displacement, we're going to have to use a squared plus b squared equals c squared, where this is a, this is b, and this is c, because a and b will be beside the right angle. So let's plug in our values. I know a, that is 4 squared, and I know b, which is 3 squared, and I'm trying to figure out c. So that's my variable that's still left over. So if I do the math on this, then I will see 4 squared is 16, 3 squared is 9, and when you add those two together, you end up with a total of 25. But let me rewrite it a different way, because I think that's a little confusing. Let's leave our variable in. So we have 4 squared plus 3 squared equals c squared. So when you add 4 squared plus 3 squared together, you get 25 equals c squared. So now if I need to solve for c, I have to do the opposite operation of squared. So I will have to take the square root of both sides. So the square root would get rid of the squared, so I end up with just c, and then I do square root of 25 is 5, and that would be 5 meters. So my displacement would be 5 meters. But look carefully, because don't jump into math before you have to, because sometimes they'll just give you the distance. So if you notice right here, if we had looked carefully at our diagram, we would see that they already gave us our displacement. But if not given this distance, they're going to expect you to calculate this distance by doing a squared plus b squared equals c squared and solving in this way. Alrighty, everyone have a great day and see you next time.